Hello, this session will be on the following fraction skills. So session 1 will be covering how to simplify fractions, turning improper fractions to mixed fractions, turning mixed fractions to improper fractions, so back and forth, looking at equivalent fractions and how to identify if they're equivalent or not, and then ordering fractions. By making fractions have the same denominator, we can see which fraction will be larger than the other. Okay, so we'll get started. To simplify fractions, all you have to do is divide both numerator and denominator by the same number or factor. If there is no number that can be divided into the numbers, both numbers evenly, then you can't simplify it. Now, a trick is whenever you see two even numbers, you know straight away they can be divided by 2. So with the first one, we have 2 and 4. So I know that I can divide both of these by 2. And we're left with, well, 2 divided by 2 is 1 over 4 divided by 2 is 2. Okay, so it's really important that what we do to the bottom, we must do to the top and vice versa. So if I decided to divide this numerator by 4 and the top one by 2, I've made a big mistake. It has to be the same number. So with B, I can see that they're both even, and I can start dividing by 2 and keep dividing by 2 until eventually I can't simplify anymore. But try and think of higher factors that are factors of both of these numbers. And I know my 8 time tables, and I know that 8 times 7 is 56, and 8 times 8 is 64. So a higher factor of these two numbers is actually 8. So if I divide them both by 8, it saves me some space and working out, but if you started dividing by 2, that's fine. You just keep going until you can't go anymore. So 56 divided by 8 is 7, oops, a funny 7, over 64 divided by 8 is 8. And check your numbers, I have 7 and 8. I can't simplify these anymore, so that's my final answer. With C, now if you look at C, they aren't even numbers. There's 25 and 55, but another trick is if they both end in 5 or end in 0, if they have a 5 or a 0, you can automatically divide them by 5. That's another trick for you to remember. So if I divide 25 by 5, I have to divide 55 by 5. Must do the same thing, top and bottom. And then 25 divided by 5 is 5. 55 divided by 5 is 11. Check your numbers. I can't simplify 5 and 11 anymore, so that's my answer in simplest form. Now if you have a look at this fraction here, this is a mixed fraction where we have a whole number, so the big 2's out here, and then the fraction part here. On your calculator, if you were to show this as a decimal, you'd have 2 point something as a decimal. So 10 over 12 is your decimal part. And if you push 10 divided by 12 on your calculator, you will get 0.8333333 and so on. So the 10 divided by 12 is the decimal part, and this is just a whole number. Now, we don't have to worry about this whole number. This whole number won't change. What can change is the fraction part. 10 and 12, I can simplify further. I can divide 10 by 2 because 10's an even number. I can also divide 12 by 2 because, 12 is even. So just remember the 2 stays the same. So we have 2, 10 divided by 2 is 5, over 12 divided by 2 is 6. And now my mixed fraction is simplified in a better way. Okay, so simplifying means just dividing by the same factor, the same number. The higher the factor, the better it is because the less working out you have. But if you can't think of the highest factor, that's okay. Just keep dividing and simplifying until you can't simplify anymore. Next thing is turning improper fractions to mixed fractions. Now, an improper fraction is a fraction where the number on top is larger than the number on the bottom. Okay, and we know that we call the top number numerator, the bottom number denominator. and D for down. Now, if I have a look at this, 9 is bigger than 7 and it's on top. So this fraction is improper, and it's not a good idea to leave your fraction like this because it doesn't really make sense in real life context. For example, if I said to you, can I have 9/7 of a pizza, or 9/7 pieces of pizza? It doesn't really make much sense. But if I did this, okay, well, now this is saying 9 divided by 7, and you can put that on your calculator and you'll get 1 point something, okay? But without a calculator, we can still see what the whole number will be. So instead of going 9 divided by 7, another way is to go, well, how many times can 7 fit into 9? So I'll write that down just to keep in mind. How many times can 7 fit into 9? Okay, so you can either say 9 divided by 7, or how many times can 7 fit into 9. We're doing the same thing. And I know that 7 can fit into 9 once, so that's where I write my big one. And then how many left over do I have? So if I'm at 7, I have 7, 8, 9. That is 2 remainder over. Now we always keep the same denominator, 2 over 7. Okay, and I've turned my improper fraction into a mixed fraction. And these two fractions are exactly the same. But this one here is telling me I have 1 whole and then 2 sevenths. Whereas here, I couldn't see how many wholes I had. And here I can see, well, if it was pizza, I've got 1 whole pizza plus 2 pieces out of 7 that's left. And it makes a bit more sense. So let's try another one. I'll squeeze it down here. For B, let's see what happens if we have 20 over 11. Okay, so once again, how many times can 11 fit into 20? And we know it's improper because 20 is bigger and it's on top. Well, I know 11 plus 11, or 11 times 2 is 22. So it can't fit in 2 times because it's gone over 20. So it can fit in once. Okay, and then we're still at 11. And how many more do I need to reach 20? So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 9 remainder over, and we always keep the same denominator. Over 11, and that's your answer. We'll try another one. We'll do these 3 more questions. And we've done it. It should be enough for you to be getting the hang of it. Now, with this one here, with C, we have 15 over 4. Once again, these are all improper fractions because the numbers on top are larger than the numbers on the bottom. And let's have a look. So how many times can 4 fit into 15? Well, we can just count by 4s. So 4, 8, 12, 16, and we've passed 15. So it can fit 3 times. And because I know 4 times 3 is 12. And if I'm at 12, how many more do I need to get to 15? Well, 12, 13, 14, 15. So that's 3 over 4. And that's your final answer. And of course, I forgot to mention before, just make sure we check our fraction part. Can we simplify 3 and 4 anymore? No, we can't. So that's our final answer. So we have 3 3/4, which makes more sense than 15 over 4. All right, this one down here, I've got 16 over 4. Yes, it's an improper fraction, but sometimes you can divide this straight away because I know that 16 divided by 4 is 4. Or the other way of doing it, 4 into 16 can fit 4, 8, 12, 16. It fits in 4 times evenly. We have no leftovers because we reached 16, and so we have no fraction part. And we know that 16 divided by 4 is just 4, and that's it. We leave it like that. Now with E, you notice that E, we can simplify it now if we wanted to, or we can leave it till later. So I might leave it till later and you'll see what I mean. So now once again, how many times can 8 fit into 12? Well, I can see it can only fit in once because 8 times 2 is 16 and I've passed 12. So if I'm at 8, how many more for me to reach 12? So 8, 9, 10, 11, 12. That's 4. Keep the same denominator over 8. Now, if you have a look at this fraction here, 4 over 8, they are both even, which means I can now simplify these even further. Okay, I can divide the 4 by 2 and the 8 by 2. Now, that wasn't the highest factor, but let's see what happens. So we have 1, and 4 divided by 2 is 2. 8 divided by 2 is 4. Have I finished simplifying? No, we've got a 2 here and a 4. Let's keep going. I can divide it by 2 again. Divide it by 2 again, and I'm left with 1. and 2 divided by 2 is 1, 4 divided by 2 is 2, and finally I have 1 and a half. And I can see that I would have ended up with a half because if I have 4 over 8, I know that 4 is half of 8. So this is telling me a half. So that should be your final answer. So when doing this, just make sure that you simplify and check your final answer, that it's in simplest form. And just remember to turn an improper fraction to a mixed fraction. All you have to do is go to the bottom number and say, how many times can this number fit into the top number? And mixed fractions, you have to have a big whole number, then your fraction part. But of course, sometimes you can have your big whole number and no fraction part because it fits in evenly. So now turning mixed fractions into improper fractions. So we're doing the opposite. And it's really easy. All you have to do is remember 2 things, and that is you times first and then plus. So just like BODMAS or BIDMAS, multiplication comes first. So all we have to do now is go 5 times 2 is 10, and 10 plus 3 is 13. And 13 is now our numerator, and just remember our denominator always stays the same, so 13 over 5. And we're done. So this fraction and this fraction here are the same fraction. And if you want to double check, we can go backwards and say, how many times can 5 fit into 13? I know 5, 10, that's 2 times. Remainder to get to 13 is 3 over 5. And you can do a quick check to make sure you haven't made a mistake. So for B, once again, times first and then plus. So 5 times 3 is 15, and 15 plus 1 is 16 over 5. Keep the same denominator, and we're done. And like I said, do a quick check. 5 into 16, 5, 10, 15 goes in 3 times. Remainder 1 over 5. Perfect. And last one here, once again, you put your times first and then plus. So 6 times 10 is 60, and 60 plus 5 is, I'll squeeze it here, so 60 plus 5 is 65 over, keep the same denominator, which is 6. And we're done. So turning mixed fractions into improper fractions, all you have to do is remember to write in times first and then plus, multiply your numbers, then add the product with the number on top, and of course you keep the same denominator, and you're done. Okay, our next skill we're learning on fractions are equivalent fractions. And just remember, equivalent means equal or the same. And sometimes, even though fractions look different, they're actually the same number. And we'll start off with an example of having 2 pizzas. So I've got 2 pizzas here, and we can say Tom and Bob. So Tom and Bob have their own pizzas, and they've cut them up in their own way. We can see that Bob has more pieces than Tom. Now, Tom decides to eat 2 pieces of his pizza. So I'll shade in what Tom ate. So imagine it was gone, and he's got 2 pieces left. So Tom ate 2 pieces, and Bob, well, he decided to eat 4 pieces. So 1, 2, 3, and 4, he ate 4 pieces. Now, to write this as a fraction, we know that to write Tom's pizza, the amount of pieces he ate as a fraction, we count how many pieces do we have all in total altogether? 1, 2, 3, 4. So Tom had 4 pieces, and out of 4 pieces, we can see he ate 2. So that's Tom's fraction of the amount of pieces he ate. And Bob, well, Bob's a bit different because he cut up his pizza into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So his denominator is 8. And he ate 1, 2, 3, 4 pieces out of his 8. Now, if I asked you who ate more pizza, Tom or Bob, you can actually see visually that they have eaten the same amount. We can see they both have eaten half of their pizza. Even though Bob had more pieces, he ate 4 pieces, and it sounds like a lot more than Tom's 2 pieces, we can see that Tom's 2 pieces of pizza were actually quite large compared to Bob's. And altogether, they both ate half. And we can see that 2 out of 4 is a half. and 4 is half of 8. So if we simplify these two fractions, and we know how to simplify, we must divide the top and bottom by the same number, and the common factor is 2. So 2 divided by 2 is 1, 4 divided by 2 is 2. Here, the highest factor of 4 and 8, you can divide it by 2, but I can see a higher factor of 4 is actually 4, and it's a factor of 8 as well. And 4 divided by 4 is 1, 8 divided by 4 is 2. And we can see how we end up getting half and half. If we kept our fractions as 2 over 4 and as 4 over 8, we couldn't see our half clearly. So by simplifying your fractions until you can't simplify anymore, we can see if they are equivalent or not, or whether they're the same. And our end result, Tom, we got a half, Bob, we got a half, and therefore these two fractions, they are equivalent. They are equal. Now, another way to check if two fractions are equivalent is using your calculator as a tool. Now, you have to also know how to not use a calculator, but if you have a calculator handy, all you got to do is go, well, 2 divided by 4 is 0.5, and 4 divided by 8, we also get 0.5. So using a calculator, if you divide, now we know that this line here, the vinculum, means division. We're actually saying 2 divided by 4. In this problem, we're saying 2 out of 4. So we can also say this line here, the vinculum means out of. It just depends on how you're using it. And we can see that 4 divided by 8 is also 0.5. And you can use a calculator to prove that. So basically, you will know if two fractions are equivalent, which are all the same, if you simplify them all the way you can go, and if their fractions are exactly the same, one on top, 2 on the bottom, you can say they are equivalent or equal. And the fastest way, of course, is using your calculator. Just divide your numbers. If you have the exact same decimal, then of course they're the same number. Next question asks us, are the following pairs equivalent fractions? So are they equivalent or not? Are these fractions for A, are they the same number? And B and C. So we'll start with A. I'll just change my color. Now, to do this, all we have to do is simplify each fraction until we can't simplify it anymore. And let's have a look. 6 and 5, can I simplify 6 and 5 anymore? No, there is no number I can divide into 6 and into 5. So that's done. 30 and 25, however, I know that 30 and 25, they can both be divided by 5. So I'll just do that. Remember the trick, if the number ends in 0 or 5, you can divide it by 5. And we end up having 30 divided by 5 is 6, and 25 divided by 5 is 5. And what do we notice? I ended up getting the same fraction as this one here. So I would say these two fractions, imagine writing the sentence, these two fractions are equivalent. Okay, you can write the sentence, or if you wanted to, in your answer, you can put an equal sign saying they equal each other. It's your choice. Now with B, have a look at B. We've got 2 and 7, and then we've got 3 over 8. Now, 2 and 7, can I simplify this anymore? I can divide the 2 by 2, but I must divide the 7 by 2. Can I go 7 divided by 2? No. So that's been simplified. And let's try this one. I've got a 3 on top. If I divide by 3, that's fine, but 8 divided by 3 I can't do. So guess what? These fractions have already been simplified for us. Do they look the same? We can see that they're different. So we can say, therefore, they are not equivalent. And the other symbol you can use is, in between these two fractions, you can write the equal sign with a dash going through, saying they are not equal to, they are not the same. It's your choice what you want to write. You can write the sentence or put the symbol, but just make sure you show your answer clearly. And the last one, C, we've got 12 and 48 and 18 and over 24. Let's see if they're the same fractions. I can see they haven't been simplified. Now, let's go. Now, 12 and 48 are both even, so you can start dividing by 2. But I know a higher factor of 12 and 48 is 12. So if I divide 12 by 12 and I divide 48 by 12, I end up with 1 over, and 48 divided by 12 is 4. Okay, so that one's done. Just double check, can we simplify 1 and 4 over 4? No, we can't. It's done. Now, 18 and 24. Well, I can't think. The first factor that comes to my mind is 2, so I might just divide by 2. I'm in a bit of a hurry, so I can't be bothered thinking if there's any other factors. And 18 divided by 2, I know is 9, and 24 divided by 2, I know is 12. Now, I've got 9 over 12. Is there a number that I can divide by 9 and 12 by? And you can use your calculator, but if you know your 3 times tables, I know that 9 divided by 3 works, and also 12 divided by 3. So this fraction here hasn't been simplified all the way yet. So just be careful. And then 9 divided by 3 is 3, and 12 divided by 3 is 4. And now I can see I can't go anymore. And let's have a look. I've got 1 over 4 and 3 over 4. Yes, they have the same denominators, but we can see they're different fractions. So we can say 1/4 and 3 quarters, they are not. So make sure you do the equal sign with the dash if you're using that. They are not equivalent. So that should have been your final answer. I just can't fit it on the bottom. Okay, and we have to prove this by working out and showing that they are not equal to. Yes, sometimes it's obvious if they're not equivalent or not, but sometimes it's a bit tricky because they could be larger fractions, but you have to show working out anyway. Now, our last topic for this session is ordering fractions. Now, ordering fractions, it's pretty straightforward, and this is where you have to have the same denominator to see which fraction is bigger and which one is smaller. So for example, if I have, let's see, 3 quarters, so 3 over 4, and we can call this one 8, and then I have, let's see, 3 eighths. Okay, right now I can't order these because they have different denominators. So what I have to do is make the denominators the same. And to do that, a trick is, well, can I turn my 4 into an 8? Now we can only turn it into an 8 by multiplying. And I know that 4 times 2 is 8. We cannot go 4 plus 4 and then 3 plus 4. We can never add numbers to our fractions like that. Only multiply. And what I do to the bottom, I must do to the top. Now, I'm going to have, well, I know that 4 times 2 is 8. And then we have the 3 over 8. That hasn't changed. I don't have to change this. If you want to times it by 1, I guess you can, but it doesn't change. But 3 times 2, I know 3 times 2 is 6. Okay? So I'll just rub that out. Now, if we compare these two fractions, now that they have the same denominators, I can see that 6 is greater than 3. It's larger. And this is where you can now add in the symbol. 6 over 8 is greater than 3. And that's your final answer. You should be able to use the greater than or less than sign. And on the exam, you may be asked to put this symbol in between fractions, depending on which one's larger and bigger. But you have to show some working out. So to order fractions, you have to make the denominators the same. It's the same skill you need to know when you're adding or subtracting fractions. And to make the denominators the same, you can just multiply the numbers with each other. I could have went 4 times 8 and 8 times 4 to give me 32. But I took a shortcut and I thought, well, I can turn my 4 into an 8 by multiplying it by 2. So a trick is always look at your small number and see if you can turn it into the bigger number. If you can't, the fastest option is to multiply them together. So we'll try the next question. Question here, we can see that we've got 3 over 5 and 6 over 11. We don't have the same denominators, so I need to make them the same. And to do this, I'll look at my small number 5. Can I go 5 times something to give me 11? No, I can't. So my next option is, well, I'll just multiply 5 by 11 and multiply 11 by 5. And we know that if I go 5 times 11 or 11 times 5, I will get 55 for both. But of course, what we do to the bottom, we must do to the top. So up here, I must times that by 11, and up here, I must also times the 6 by 5. Okay, and now we have 5 times 11 is 55, 3 times 11 is 33, and now I've got 6 times 5, I've got 30, and 11 times 5 is 55. Now look, we can see they have the same denominators. Now which one is bigger? Have a look on top. Well, I can see 33 is bigger than 30. So I will, in between these, as my final answer, I will say 33 out of 55 is greater than 30 out of 55. And that's your final answer. And to put it in a real life context, imagine I said to you, okay, our pizza's cut up into 55 pizzas. It's a huge pizza. This pizza, somebody ate 33 pieces, and this one they ate 30. Who ate more? Obviously, 33 pieces of pizza is more. And we'll do one more. Now, if we have a look at these two fractions, once again, we have to order them, and we need them to have the same denominator. To do this, we don't have to simplify. I can easily change my 8 into a 24 by multiplying it by 3. What you do to the bottom, you must do to the top, times by 3. So my new fraction, this fraction stays the same. I've got 12 out of 24, and 4 times 3 is 12, and 8 times 3 is 24. Now let's have a look and see what we have. Do I have a fraction that's bigger than the other, or are they equivalent? I can see they're equivalent. They're exactly the same fraction. If I had simplified this fraction and simplified this fraction, if we simplified them, they would both equal a half. So if we were doing equivalent fractions and we simplified, we would have gotten a half for both. And if you have a look, it's really, if we end up with the same number by changing our denominators, it's another way to figure out if fractions are equivalent or not. Because if they have the same denominator and the same top, well, they're equivalent. So now in here, I don't put the greater than sign or the less than sign. I put the equal sign, saying these two fractions are actually equal and neither is bigger than the other. And that will be your final answer. So just keep in mind that sometimes you have fractions that are larger than others or smaller, and sometimes they can be equal, they can be equivalent. So just make sure you're okay with what we have covered. So in this session, as a summary, we have covered the 1, 2, 3, 4, 5 dot points. And if you still need extra help, make sure you let your teacher know. Thank you.